Then properties of the material. Properties of the material. A material can be stiff. A material can be brittle. A material can be malleable. A material can be ductile. A material can be strong. A material can be tough. A material can be hard. Or material can be flexible. Now, what are the definitions? I shared one file with you. All the definitions are there. So I will just explain the concept, the meaning of each term. The term stiffness means, a stiff object means object will show a greater force is needed is required to produce a small extension. Or normally the stiff objects have higher value of K or Young's modulus. Why? K is a constant, Hooke's law constant, and Y is a Young's modulus, the ratio between stress and strain. So when the material is stiff, like example, you have, it can be force or extension graph, or it can be stress and strain graph. You have two objects. Which object you need a greater amount of force to produce a small extension, a small change in length, A or B? For A, we need a greater amount of force to produce a small change in extension as compared to B. You can, how you can work out? You can work out from the same extension. Like example, if for the first one, B, we need a small amount of force to produce, example, 2 centimeter extension. But for A, we need a greater amount of force to produce the same extension. So higher value, and when you work out the slope or Young's modulus, you will get this higher value for A as compared to B. So A is stiff material as compared to B. What is a tough material? An example of a stiff material, like example, when you take iron rod. Iron rod, if you want to deform the iron rod, you need a greater amount of force to produce a small change in length or deform or extend. So iron rod is a stiff material. Tough material means object can absorb greater amount of energy before breaking. So when object can absorb greater amount of energy before it breaks, what we call object as a tough. And for tough objects, if the object is tough, it will have greater area under the graph. Means the graph, when we work out, it will have a greater area. So you have two objects, one is A, another one is B. Which is tough object, which is having a greater area, A or B, under the graph? Because area under the graph shows energy stored in the material. If it is force and extension graph, it is energy stored. If it's stress and strain graph, that is called energy density. That we will discuss, energy density. So which material is tough? So B is a tough material because when you find the area under the graph for B, B is having a large area. But for A, smaller area. An example of the tough material, like example, tires. Car tires are tough because they can considerable deformation can occur for them before they tear or break. So if an object can undergo greater deformation, any kind of deformation, elastic or plastic, before it teared or break, we call that as tough material. A brittle material no or small plastic deformation and object break. So either it is no or very small plastic deformation and the object break, we call that as a brittle. So how you can work out a brittle? So there should be either no deformation or very small plastic deformation. So if you have a force and extension graph, force is on y-axis and extension on x-axis, which material is brittle, A or B? So A is the brittle material because it should show a small deformation, no or very small deformation. For A, this is a deformation. For B, there's a greater deformation. The first thing, when you are checking a brittle object, you will check there should be no deformation or very small deformation and the object should break. If two objects are showing the same deformations, then in that case, the object which break down because of smaller force, that is the brittle object. So which is a brittle object in this example, A or B? The second one. Which one is a brittle? So B is a brittle object because it shows no or very small deformation and breakdown. Then malleable and ductile, a small difference is there. Malleable means you can hammer them into shape. Malleable means hammer into shape, and ductile means can be stretched into wire. And meaning of malleable means it deformed under compression, because when you hammer something, you can make it into shape. And here it will deform under extension, means you extend or stretch something. So like example, if I have an object, I'm hammering it. So what I will call, and I am hammering it and making it to a certain shape, I will call that as malleable. But if I have an object, I'm stretching the object to make a wire, what I will call that as ductile. So that's the difference. Both deform under force, by applying force, but one we have a compressive, here we have a compressive stress, and here we have a tensile stress. And the graph, there will be more plastic area, like plastic region is there, so we can identify that the which is better to make wires and which material is good for or malleable. This part we will continue in the next session. So today mainly we discuss stiff, tough, brittle. Malleable and ductile I will go through next class as well, so that you can understand. Any doubt related to the class?